Welcome once again to Mathematics Mayor, a wonderful program for wonderful people like you that is watching the program now. A program where we use simplified methods to make sure that students understand the concept of mathematics. Today on Mathematics Mayor, we are still looking at the concept of plane geometry, and we're looking at part 2 of plane geometry. Remember, plane geometry 1 deals with angles on a straight line and angles at a point, corresponding angles, and the alternate angles, and also vertically opposite angles. So generally in plane geometry 1, we looked at angles on lines. But in plane geometry 2, we are looking at plane shapes as it concerns angle, because geometry has to do with the study of lines, angles, and shapes. So in plane geometry 2, we started looking at shapes. Please make sure that you subscribe to our YouTube channel and also like our Facebook page. Follow us on Facebook so that each time we upload a new video, you will know about it. So far, we have looked at the meaning of plane shapes, and we have also considered some descriptions about plane shape. And then we looked at polygons. So you need to watch the first video for you to actually follow up with what we have done so far. That's the part 1 of this plane geometry 2. So plane geometry 2A, just watch the video for you to actually understand how far we have gone in the study of plane geometry. Now today we are looking at the last objective on plane geometry 2. Remember, we started with the meaning, that's the general description of plane geometry. Then we looked at polygons and descriptions of polygons. Then we said that the last aspect we just cover calculations of angles in what? In polygons. And for us to do these calculations, there are important points that we need to take note of. And that's where we are going to begin. So let's start off this journey now on calculations. So we'll still clean this, so let's begin with this part of the board. So calculations of angles of polygons. Now, before we delve into the calculations of angles of polygons, there is need for us to consider few points, very, very important points that we need to consider. So we begin this way. Before we commence the calculations of angles of polygons, we must note some important points. There are important points that we must take note of, because these important points, they will help us in our work, in our calculation. So we'll be dividing these points into various parts. So part A. So part A of it. So AI. We are going to have B also, and we have C. So AI. What's the first point we need to take note of? A regular polygon is a polygon with equal sides and also equal angles. When all the sides of a polygon are equal and also all the angles of a polygon are equal, then that polygon is said to be what? A regular polygon. So in a regular polygon, the sides are equal and also the angles are what? Equal. in a regular polygon. For example, if you look at a square, you notice that the sides of a square are all equal. We look at a square, for example, you know a square now. In a square, the sides are equal. This side, that side, that side, that side, they are all equal. And each of the angles is also 90 degrees. They are 90 degrees. So the angles are equal to each other, and the sides are also what? Equal. When you have such a polygon, that polygon is said to be what? A regular polygon. A regular polygon. So that's the first thing we look at, part A of this. Number 2, in A, we say that a convex polygon is a polygon that does not contain a reflex interior angle. So a polygon that does not contain a reflex interior angle is a convex what? Polygon. You know what we mean by reflex angle? An angle that is above what? Above 180. So when you have a polygon and none of the interior angles is what? Is a reflex angle. So in other words, all the interior angles are less than what? 180. In any polygon where all the interior angles are less than 180, that polygon is said to be what? A convex what? Polygon. So in a convex polygon, all the interior angles are less than what? 180. So a convex polygon is a polygon that does not contain a reflex interior what? Angle. And we say a reflex angle is an angle that is greater than 180. So if a regular polygon does not contain a reflex interior angle, it means that the angles there, none of them is reflex angle, none of them is greater than what? 180. So any polygon that does not contain an angle, an interior angle that is above 180, that polygon is said to be what? A convex what? Polygon. A convex polygon. So in a convex polygon, none of the interior angles. In a convex polygon, let me put it this way: all the interior angles. Convex polygon, all the interior angles are less than 180 degrees. So in a convex polygon, all the interior angles are less than what? 180 degrees. Then we have the third one. In a rectangular polygon, at least one of the interior angles is greater than 180 degrees. So in reentrant polygon, at least there will be a reflex angle. Yeah, one of the angles will be greater than what? 180. So in a convex polygon, no reflex angle as interior angle. But in a reentrant polygon, at least one of the interior angles is what? Greater than 180. Greater than 180 degrees. One of the interior angles. Okay, still on A. No, we need to make this point very clear, very, very important. Now, most times people rush to do calculations in mathematics without understanding the concept, knowing the basic things. And when they now begin to do calculation along the line, the thing will begin to choke. And then they will not be able to breathe. So at that time, they will be in serious trouble. That's why it's important that you understand the concepts very, very well. All the things that you need to know in a particular topic, you need to first of all understand them before you now start calculation. Someone will say, oh, you are writing too much. No, we are not just here to do calculation. We want to make you to become mathematics. Yes, we want you to become mathematical in nature. Yeah, that's why we need to actually put down some of these important points in all the topics that we have handled so far. Okay, then third, in a given polygon, the number of angles is also equal to the number of sides. So if you have a polygon and there are 4 sides in that polygon, that means that polygon will also have 4 angles. You get that now? So if a polygon has 4 sides, the polygon will also have 4 angles. So the number of sides of a polygon will also tally with the number of angles that are obtainable in that polygon. So finally on the A, the angles inside a polygon are known as interior angles, while the angles outside the polygon are known as exterior angles. So in a polygon, we'll be dealing with 2 different angles, the interior angles and the what? Exterior what? Angles. So the angles inside the polygon are known as what? Interior angles, while the angles outside the polygon are known as what? Exterior angles. So we'll be using this term interior and exterior. So if I have, let's say I have this pentagon, 5-sided polygon, I have this, maybe regular or irregular. Let me put it in another way. This one looks like a house, but let me put it in another way. Something like this. So let's say we have this. Now we have that, we have that, and have this, and have this, I can have that. Now these ones, these angles here are interior angles. 1, 2, 3, 4, 5. They are inside the polygon, so they are interior. But you see these ones here, the one I dotted, the dots. These ones are what? Exterior angles, because they are not inside the figure. They are not inside the polygon. So we'll be dealing with interior angles and what? Exterior angles. Once we are handling calculations in polygons, as far as angles are concerned, you will be hearing about interior angles, exterior angles from time to time. Okay. So that's all for the important points A. Then we move to B. For all polygons, the following general points exist. For all polygons, the following general points exist. First, sum of the interior, sum of the exterior angles of a polygon is equal to 360. So sum of all the exterior angles in a polygon will give us what? 360 degrees. That's one important point. 2, sum of the interior and corresponding corresponding exterior angle is 180 degrees. So some of the interior and exterior angle of any polygon is 180 degrees. Now, sum of the exterior angles of a polygon is equal to what? 360. That means when you add all the exterior angles, you are going to have 360 degrees. Now, we have to move on to all these points. Before we start our calculations, we must take note of all these points. Very, very important. Very, very important. So, the third point here, the number of sides of a polygon is denoted by n. So we shall use n to represent the number of sides in a polygon. So for all polygons, a sum of the interior angles is given by Sn plus n minus 2 times 180 degrees. In some cases, we use xn equals 2n minus 4 times 90 degrees. Okay? So sum where xn is sum of interior angles of n-sided polygon. So we have said that n is the number of sides. So the sum of any n-sided polygon will be given by n minus 2 times 180 or 2n minus 4 times 90 degrees. Now, this expression was obtained from here. When I say 2n minus 4 times 90, if you factor out 2, you have n minus 2 times 90. And when 2 multiply 90, you now have this. So the number of right angles, you remember that when we started, we looked at the number of right angles and the number of triangles present in a given polygon. So the number of right angles gives us the sum. So this 90 degrees is right angle. A triangle has 180 as the sum of the interior angles. So n minus 2 times triangle, 2n minus 4 times 90 degrees, and 90 degrees is right angle. So this is the expression for calculating sum. In the table in our first class, you will discover that there is a column for number of right angles. Like for triangle now, a triangle has 3 sides. So the sum of a 3-sided polygon now, sum of the interior angles for a 3-sided polygon, all we need to do is to put 3 here now. So it becomes 3 minus 2 times 180 times 180. And 3 minus 2 is 1. 1 times 180 will give us 180. That's sum of angles in a triangle. Now, how many right angles are there if we now move with this? 3 times this will give us 6. 6 minus 4, 2. So we have 2 right angles in a triangle. So that when 2 multiply this, we have 180. In some cases, they may tell you that the sum of angles in a given polygon, they may give it to you in terms of right angles. So this is the expression for the sum of angles, interior angles of what? Of a polygon. All right. Now we move to C. We move to point C. For regular polygons, must note the following for regular polygons. Must note the following. 1. The interior angle each interior angle, let's use that to make it clearer. So each interior angle is denoted by I, while the exterior angle is denoted by E. Therefore, I plus E is equal to what? 180. Coming back to this place now, so that some of the exterior angles is that some of the interior and corresponding exterior angles is what? 180. It's 180. So when you add interior angle, each interior angle plus the corresponding exterior angle give us 180. Now, why are we doing this? Because this is a regular polygon, so all the angles are equal in a regular polygon. So we can actually use I to represent each of the angles, so that will simplify a lot of things. Since all the angles are what? Are equal, we can use E to represent each of the what? Exterior angles. So if I have, let's say I have this 1, 2, 3, 4, 5. Now this is still a pentagon. If this is a regular pentagon, you will notice that this angle, this angle, this angle, this angle, and this angle, all of them will be equal. Interior angles, if it's regular, so here will be I, here will be I, here will be I, here will be I. And then the exterior angle, here will be E, here will be E. Let's make it bigger somewhere here. Let's make it bigger somewhere here for clarity. Let's make it bigger somewhere here. So we have this. If I have, let me still use a pentagon. Let's still use a pentagon. Or let me use a hexagon. Now we have used pentagon a lot. So let's use the hexagon. Okay. This 6-sided 1, 2, 3, 4, 5, 6, 6-sided polygon. And then I can extend this that way, that way, that way, that way, and then maybe that way. Now, if this is regular, the sides are equal and the angles are also equal. So if the angles are equal, we can say that each interior angle is I. So this should be I, this should be I, this should be I, this should be I, and this is I. Then the exterior angles are also equal to each other. So this E, each of them E, each of them E, this E, and this E. Now if you look at this from the knowledge of geometry 1, this is a straight line, and sum of angles on a straight line will give us what? 180. So you now see that I plus E is 180. That's the origin of this. You see that now? That's the origin of this. So for a regular polygon, we just need to know that the angles, the interior angles, all are the same. The exterior angles are also what? The same. Okay. So we have established that. Now we do one more thing from here now, or two things more from here. Just follow me, because we want to make life easy for you when you want to do calculations. Now, can you see that this is a 6-sided polygon, right? Now, if I want to add the exterior angle, so I can say point number 2 now, point number 2, from the above figure, the sum of the exterior angles, sum of the exterior angles is given by E plus E plus E plus E plus E plus E Now, because this is a hexagon, how many e's do we have? Remember, we said that the number of sides also will correspond to the number of angles. So, if you do this, e plus e plus e plus e plus e plus e will give us what? 6e is what? 360. I'm not trying to find e. Don't go there. I'm not trying to find e. What does 6 represent? 6 represents the number of sides. The number of sides. That's what it represents. Which is n. Therefore, for a regular polygon, we have, for a regular polygon, if I now replace this 6 with n, because this 6 represents the number of sides, because 1, 2, 3, 4, 5, 6 sides. That's how we obtain these 6 angles. So if it is for 5-sided polygon, we know we have 5 there. If it is for 3-sided polygon, we still have n there. If it is 10-sided polygon, it is 10 that we have there. So this 6 is representing number of sides. So if for n-sided regular polygon, so therefore for a regular polygon, or let's say for n-sided regular polygon, therefore for n-sided regular polygon, we have that n times the exterior angle will give us what? 360. So the number of sides times each exterior angle will give us 360, because all the angles are what? Are equal. Then, similarly, for n-sided regular polygon, the sum of the interior angles is given by S n equals n times I, where I is each of the interior angle and n is the number of sides. Now remember that already we have established something for sum. We said that sum is n minus 2 times 180. That's sum. So quickly I can replace this here. I will now say that n minus 2 times 180 is something as n times I. So since sum is this, I'm using the whole of this now. I'm using the whole of this to replace sum. All these expressions, we are going to see the benefits. We are trying to make sure that the calculations in polygons become very easy. Okay, finally, on the important points. We are on D. This one is specifically for triangles. D. In a triangle, sum of the interior angles is 180 degrees. We keep that, I. Then sum of two interior angles, sum of two interior angles will be equal to an exterior opposite angle. So if I have this is a triangle. We are still going to consider this when we are dealing with angles in a triangle. We treat that as a separate topic or subtopic in plane shapes and angles. So if I have this is a triangle. Let's say here is A, here is B, and here is what? C. Let's say here is D, here is E, and here is what? F. A, B, and C are interior angles. So in a triangle, sum of the interior angles is equal to 180. So if I add A, B plus C, I'm going to have what? 180. Then the second point, there's a sum of two interior angles will be equal to an exterior opposite angle. Two interior angles. Which exterior angle is opposite? E. So this plus this will give me this. This plus this will give me this. While this plus this will give me this. So from here, A plus B is equal to E. Following this point, then A plus C will be F, and then B plus C will be what? D. Will be D. Our interest mainly is from points A, B, and C. We just have to mention this in case if we are solving any problem in general polygon and we encounter a triangle maybe within the polygon, we will not be confused. We will not be confused when we now begin to invoke this. All right. So far so good. We are going to go on a short break. Take time to digest this. There are not so many. By the time we return, I'm going to write out some of these points on one part of the board. Then we will now begin to look at calculations. Mathematics is sweet. We have over 50 questions available for us to solve as far as polygons are concerned, angles in a polygon, and we are going to do justice to that. As we are solving, we also be giving you some takeaway questions because we want you to be balanced. All right, continue to enjoy our videos on mathematics here. We shall be back to finish up on polygons. Thank you, and God bless you.